Hi, in this video we will do some examples which are related to the limit of sine x over x as x approaches to 0 is equal to 1. Before I start, I just want to add something to this limit that while you have to see x as a placeholder, so you can replace x by anything you like. And to be able to say that that limit is 1, you have to check two things. One is that whatever is in front of a sign, whatever is inside sine function, it should be divided exactly the same thing. The denominator should be exactly the same thing. And that thing is approaching to 0. If you have that form, you can say that that limit based on what we showed is equal to 1. In other words, you can always do substitution. Let that box to be your x, and then you have this limit. Okay, so here let's just start working on this one. This is inside sine we have 3x, so let me put inside box. In the denominator, I need to have the same number. So it will be 3x. I just multiply denominator by 3. But you will say, okay, you changed something. Yes, you're right. I have to multiply the whole thing by 3 outside. So this x approaches to 0. Now, you see what is inside x, denominator has exactly same thing. That's nice. One thing else that now we have to check that 3x also approaches to 0. Well, yes, when x approaches to 0, 3x is also approaching to 0. So let's just call this guy our new x, or let's say y. Then we have 3 limit of sine y over y as y approaches to 0. Well, you see, this is now exactly the placeholder x is replaced by y, and then we have 3, the limit is 1. And you see, this gives us the limit is equal to 3. How about this one? Okay, so first I want to generate exactly same form, sine of something over another thing. Here, I will put sine of x. You see this x squared, I'm taking to the denominator of the denominator. Okay? What will remain in the numerator? Well, this is just 1 as x approaches to 0. And you say, okay, very nice. This piece is all right, yes. But this piece, I have to multiply by 5 and divide by 5. And what we will have is that, well, apply the quotient law and the multiplication product law, you will have limit of sine x over x as x approaches to 0, 1 over that. Multiply to 1 over, well, constant multiple law, this will be limit of sine of 5x over 5x as x approaches to 0. And then you multiply these two. Yes, this is... Well, the first limit is 1 over 1. This is exactly what we have there. The second limit, well, you can switch 5x, as x approaches to 0, we know that 5x also approaches to 0, yes? And then I take this guy and call it y, and then put in the denominator as whole thing. So y goes to 0, sine of y over y. And now this is again the same limit, and it will give us 1 over 5 times 1. And that gives us the whole value, the value of the whole limit. Yes, it's 5. Oh, 1 over 5, sorry. 1 over 5. Okay? How about this one? Okay, I don't have any x's here. Sine of 5x over sine of 7x. Well, what we can do, the trick here is that, okay, I need in the denominator of the numerator, I need 5x. Yes. Then I multiply the whole numerator. Let me write a little bit further away. Then I do 5x here in the numerator. And then I need a sine of 7x is in the denominator. I need a 7x in the denominator of the denominator. So I can get it by doing this as x approaches to 0. And as you can see here, now I can cancel these two, and I have 5 over 7 times limit of sine of 5x over 5x as x approaches to 0, and limit of sine of 7x over 7x as x approaches to 0. Now, well, this is already now clear what to do. 5x, take it y, and as x approaches to 0, you see that y will approach to 0. And take 7x in the denominator to be z. As x approaches to 0, you see that z approaches to 0. So what we have here is 5 over 7 times limit of y approaches to 0 sine of y over y, and in the denominator sine of z over z as z approaches to 0. And while here in the numerator I have the limit sine y over y, which is 1, sine z over z as z approaches to 0 is 1. So the whole limit is equal to 5 over 7. So you just generate that sine box over box and make sure that box goes to 0. And while this one is a little bit different case, but well, we can deal with this. Now you see, as x approaches to 2, x minus 2 approaches to 0. Yeah. So if I call this guy y, what you notice, let me rewrite this guy here, x minus 2. In the denominator, we actually have x minus 2 times x minus plus 3 as x approaches to 2. Yes. So now I can switch all this y minus 2's to y. Yes. What will happen to x plus 3? X minus 2 is equal to y. Then x is going to be y plus 2. Then x plus 3 is equal to y plus 5. So this guy here is going to be y plus 5. And then what you have is x approaches, or I will do the substitution, that y now approaches to 0. Sine of y over y, and then there's another piece, 1 over y plus 5. And while the limit of this first piece is 1, the limit of the second piece is 1 over 0 plus 5. And that will give us 1 over 5. Sine of box over box as box approaches to 0. So we did do that operation. Okay, and the very last example now here is we have infinity limit. Sine of x, sine of limit of x times sine 1 over x. as x approaches to plus infinity. Remember that when you have plus infinity of limit at infinity, you can replace or change it to limit at 0 by letting t go to 0 plus and f of 1 over t. Now we apply the same thing here. So we have limit of t goes to plus infinity 1 over t sine of, replace all x's by 1 over t. And this gives us limit of t, t goes to 0 plus, not infinity anymore. So t goes to 0 plus, sine of 1 over t is t over t. Yes. So this guy has limits. So the left limit and right limit are equal. And well, I don't need to consider one-sided limit. That's the limit we have. There's only one comment here, that if you don't confuse this limit with the limit when x sine of 1 over x as x approaches to 0. Don't confuse that with that one. The limit, if x approaches to 0 is 0. You can go back to notes and videos. You can see that in applications of squeeze theorem. But this guy's x approaches to infinity is equal to 1. This is different. Okay, so these were applications or some consequences of the limit of sine x over x as x approaches to 0 is equal to 1.